Hello everyone, myself Gitanjali. Come today I will solve my third internal question paper of computer-oriented numerical methods. So question number one is obtain Simpson's 1 by 3 rule from Newton-Cotes formula. We know that I is equals to n h summation of I to 0 to n yi into ci power n. There ci n minus 1 by n integration of 0 to n li u du. So put n is equals to 2 in this equation, then we get the equation as I is equals to 2h brackets open y1 c0 2 plus y1 c1 square plus y2 c2 square bracket close. Now put n is equals to 2 and I is equals to 0 in the Cotes number. Then we get c0 square is equals to 1 by 6, and when we put the value of I is equals to 1, then we get the value of c1 square is 4 by 6, and now we put the value of I as n. Cin is equals to Cn minus I power n. Put n is equals to 2 and I is equals to 2. Then we get C2 square is equals to C0 square minus 1 is equals to 1 by 6. So I1 h by 3 y0 plus 4 y1 plus y2 I2 is equals to h by 3 y2 plus 4 y3 plus y4, and In is equals to h by 3 yn minus 2 plus 4 yn minus 1 plus yn. I1 plus I2 plus I3 dash 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 In is equals to n by 3 y0 yn plus 4 y1 plus y3 plus dash 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 mu n minus 1 plus 2 bracket में y3 plus y4 plus yn minus 2. Now this is the Simpson's 1 by 3 rule from Newton-Cotes formula. So question number 2 is obtain Simpson's 3 by 8 rule from general quadrature formula. Now the general quadrature formula is I is equals to n into h f of a h by 2 differentiation of f of a plus braces open h cube by 3 minus h by 2 into differentiation of second differentiation of function divided by 2 plus h cube by 4 minus h square by 6 plus h divide into third differentiation of function. Now put n is equals to 3 and neglecting the higher power terms containing del 4, del 5. I is equals to 3h f of a plus 3 by 2 f of a plus h minus f of a plus 3 square by 3 minus 3 by 2 versus f of a plus 2h minus 2f a plus h by 2 plus f a. Now 3 cube divided by 4 minus 3 cube 3 square by 6 plus 3 into f of a plus 3h minus 3f of a plus 2h plus 3f a plus h minus f of a. After simplification or after solving this equation, we get I is equals to 3 by 8 h braces f a plus 3f a plus h plus into f a plus 2h plus f a plus 3h. This is the Simpson's 3 by 8 rule. So the question number third is write an algorithm for Range-Kutta methods for fourth order. Now firstly we started an algorithm, and in the second step we define function f x comma y, and in the third step we read values of initial condition x0 and y0, number of steps and calculation point xn. And in the fourth step, we calculate step size h is equals to xn minus x0 divided by n. And in the fourth step, And in the fifth step, we initialize I is equals to 0. And in the sixth step, we consider a loop and give some operation in that loop. K1 is equals to h into f of x0 comma y0. And K2 is equals to h into f of x0 plus h by 2 comma y0 plus k1 by 2. And in the K3, h into f of x0 plus h by 2 comma y0 plus k2 by 2. And in the K4, h is equals h into f of x0 plus h comma y0 plus k3. And k is equals to k1 plus 2 into k2 plus 2 into k3 plus k4 divided by 6. And initialize yn is equals to y0 plus k. And iterate the loop in increase by 1. Sorry, iterative value increase by 1. I is equals to I plus 1. And x0 is equals to x0 plus h and y0 is equals to yn. And in the seventh step, we display yn as a result and stop this algorithm. And the question number four is obtain normal equations and write algorithm for linear regression. Give a data set with input feature x and target value y. The normal equation for finding the coefficient theta that minimize the mean squared error are x theta is equals to x t y. Here x is the matrix of input feature and y is the vector of target values. Xt is the transpose of x and theta is the vector of coefficient. To derive this, start with the constant function. So j theta is equals to 1 by 2m summation of I is equals to 1 to m and braces open h into theta x I minus yi square whole square. Now, where h theta is the highest hypothesis function and cost function in matrix form is j0 is equals to 1 by 2m braces open x theta minus y की power uh, braces close की power t braces open x theta minus y and compute partial derivatives as dj is equals to d theta j is equals to 1 by m into t braces open x theta minus y braces close. Set partial derivatives to 0. X theta minus y is equals to 0. X theta minus y is equals to 0. Then xt minus xty is equals to 0. Solve for theta. Theta is equals to xt x inverse xty. And this is the algorithm for linear regression. In this algorithm, firstly we start an algorithm. Second, in the second step, we read the number of data and in the third step, we initialize I equals to 1 to n in the loop for and read the value of xi and yi and next I. And in the fourth step, initialize sum x is equals to 0, sum x2 is equals to 0, sum y is equals to 0, and sum xy is equals to 0. And in the fifth step, we calculate required sum for I minus 1 to n. Sum of x is equals to sum of x plus k and sum of x2 is equals to sum of x2 plus xt into xt. And sum y is equals to sum y plus y. And sum of xy is equals to sum of xy plus xf into my yf. Now next one. Now calculate required constants a and b of y is equals to a plus bx. Now b is equals to and sum of xy minus sum of x into sum of y divide by n into sum of x2 minus sum of x into sum of x. Now a is equals to sum of y minus b into sum of x divided by and in the seventh we display value of a and b and in the eighth step we stop an algorithm.